Welcome to yet another channel on data sciences. I request you to keep an eye on youtube.com/@raven30 for regular videos on data sciences. Let us try to understand skills required for career in data sciences. However, before delving into the aspects of programming and tools, I would like to emphasize that you can be anyone from any kind of background or any kind of degree. You can still have a career in data sciences. Do not feel intimidated that only those with computer science background or engineering background can ace as data scientists or build careers in data sciences. Yes, they have advantages because they learn programming, they learn a lot of mathematical applications to solve engineering problems, but that's never going to be a disadvantage. I've seen people without any mathematical background or programming background acing in data sciences because they build that intuition on how to solve problems using data. They started asking questions on how to make sense of this data or how to use this data to make better decisions. So, in this entire journey, I strongly emphasize on knowing how to solve problems using data or how to make better decisions using data. Now, let's come to this question. Should you learn programming or should you use tools? Either programming or tools are something which pave you a path to solve certain problems. Assume that you have to collect data and clean data. You can use any of these programming languages that are open source, or you can use Microsoft Excel and SQL databases. So you can collect, you can pre-process data, and once you prepare data, you may apply this data for different algorithms, and those algorithms are available in Power BI, which is a Microsoft tool. Otherwise, you can use programming languages such as Python, R, where they provide you a lot of packages. Through those packages, you can solve these problems. Last, we have a Tableau, which is a very powerful tool for visualization. I have seen a lot of MBA students without deep programming background acing careers in data sciences by using these tools. At the same time, if you want to automate, if you expect some flexibility in the kind of solution you're designing, or if you want to apply deep learning or AI algorithms, or say you want to build cool tools like ChatGPT, in that case, it is essential for you to learn Python programming. With these things in our mind, let us go ahead and have a roadmap and what kind of skills that are required for you over a period of time. First thing is foundations in Python. As mentioned, if you start learning Python and if you do not connect yourself to Python, you can still switch to R programming or Julia programming. You can give it a try. If you are not able to connect to any kind of programming, then you can try to learn tools such as Power BI, Tableau, SQL, and spreadsheet. That said, why am I using Python programming to teach data sciences? And why is it very important? I would like to emphasize that knowing Python programming opens up different opportunities. Assume that you started learning Python programming and in course of your journey figured that data sciences is not for you. In that case, you can pivot to either full stack web development using Python, or you can move to an automation engineer using Python programming. So there are several benefits if you learn Python, and you do not have to restrict yourself to data sciences. And once you master Python programming, the next step in data sciences is to understand different types of data available and try to pre-process them. Once you pre-process using different operations on data, then you can do scientific computing, visualize, apply several statistical methods. Sky is the limit on how you're going to harness this data, make it available for your customers or business leaders. Now we can move on to an important aspect on applied statistics. Statistics has been in practice over 90 years. And an important thing is knowing statistics and applying the statistics strengthens your ground. For example, you have a data and how to make sense of it. What kind of questions to ask using this data? How is this data going to help me or my business solve a problem? Foundations in applied statistics gives you that strong footing. With that strong footing, you can confidently start exploring other machine learning algorithms. You can solve problems using time series. It might take approximately 3 to 6 months of time to master these concepts. These concepts are good enough to get going and solve a lot of problems in real time. Say you still look for improving the efficiency of your models or accuracy of your models, or try to reduce uncertainty in your predictions. In that case, there are several models that are part of advanced concepts. Natural language processing is primarily used for textual data. A lot of data is conversational in nature or textual in nature on your social media or in documents. Lately, a lot of companies are harnessing the text that is available for them to provide better services to their customers or take decisions based on the text that is available to them. There are several algorithms in NLP, and they are used for summarizing the text, identifying the names, organizations, or trying to understand the sentiment of the text that is being available to you. And they have a gamut of applications in real time. With this background, the next logical step is to try to apply neural networks in data science problems. Neural networks and artificial intelligence are more or less the same. If you are using neural networks to build your algorithms, then it becomes deep learning, and a majority of deep learning algorithms are called AI in general terms. Once you gathered these skills, your next logical step is to integrate them with your products or dashboards for your managers to take better decisions. That's where developing the dashboard comes into picture. I've seen some students and professionals building these dashboards, putting them on their GitHub, including them as a part of their resume, illustrated their projects, and they got good jobs. So that's the advantage of knowing and learning dashboards. It's not only something that helps you find a job, you can also integrate these dashboards as a part of different products or solutions offering. Next, I would like to emphasize on Bayesian data analysis. Sometimes you predict something, assume that you're predicting whether a delivery is delivered on time or not, and you give a probability of 95% that the delivery will be made on time. However, there's a 5% uncertainty. In some scenarios, you struggle to understand the uncertainty. Sometimes it may be 10% uncertain or 50% uncertain. Bayesian data analysis provides great framework to understand this uncertainty. And once you know what is the uncertainty involved, you can take better managerial decisions to improve your customer service. So that's the reason understanding Bayesian data analysis is very vital in your data science journey. Next, optimization techniques that you use day in and day out. A majority of optimization techniques are also used to solve problems of developing statistical algorithms, machine learning, or deep learning algorithms. This is going to be quite a handy tool wherein sky is the limit to harness the potential of optimization. Last but not the least, assume that there is a company, that company's customers are spread across different geographies, or the company has a product or a solution that is being sold in one geography, but its raw materials are procured from other geographies, or its logistics and supply chain are spread across different geographies. In that case, having geospatial data and taking decisions through geospatial data and different statistical machine learning algorithms is going to be vital. I would be consistently uploading videos so that you can skill yourself in these topics. And if you have any topics in your mind to suggest, or if you would like to know in detail about particular topics, kindly inform me in the comment section. Thank you very much.